Thank you for joining us. And again, sorry about the mix-up with the Zoom link, but I'm glad you all managed to join us. I'm Carla Richards. I'm the Innovation Project Manager at the Health Innovation Network, which is the academic health science network for South London. Welcome to all of you for joining us today, as we're going to be hearing from the architects of FLIP, who are going to tell us about their privacy-preserving NHS federated learning platform. We've got a panel of experts from the NHS and Academia, we're going to be hearing from, and they'll be discussing the benefits and challenges of harmonizing data across an entire region for machine learning. Our panelists today are Jorge Cardoso, who's the CTO of the AI Centre at King's College London, Haleema Jazzaf, the Senior AI Engineer at the AI Centre at Guy's and St Thomas's, and James Teo, the Clinical Director of Data and AI from King's College Hospital. I personally am really looking forward to hearing more about how we can give access to data at scale without compromising it or compromising the safety. I think there's potentially some really interesting points around data ownership and data sharing and the learning and potentially commercial models that may come from this. So without further ado, I'd like to hand over to Jorge Cardoso, the CTO of the AI Centre at King's College London.
Thank you very much, Carla. Do you mind going for the next slide? Okay, so today we're going to talk about some of the platforms and systems that we've been building at the London AI Centre to allow us to make use of large data sets that exist within the NHS in a way that is specifically focused on ensuring that those data sets are kept private, but we can still have some benefit from learning from that data. So if you go to the next slide, please. The aim of AI, when we want to use AI in the healthcare setting, is normally very broad and can really impact many areas of care, all the way from improving the way we care for patients. This includes diagnosing diseases, prognosing how those diseases will evolve, and, for example, knowing how best to treat patients. But AI can also be used in many other areas, such as improving the clinical efficiency, so making clinicians faster and more efficient at the work that they do by preparing data and making sure that they have information that they need available to them when it needs. We also want to use AI in the area of auditing. This is when we want to make sure that the services are being delivered with the right degree of quality, and to make sure that any problems in the hospital setting in terms of delivering service and delivering care, any of those problems are detected very early on, and we can have systems that are monitoring those services, again, built around AI models. We also want to make the hospital's operations themselves more efficient. For example, figuring out when patients might miss their appointments, or, for example, predicting how many beds we might have available in different services in the next week or next month. All of those things allow us to make sure that, for example, clinicians and nurses are available when needed and in the numbers that are needed. And when we put all of these components together, we create this idea of value-based healthcare, which is part of the name of the AI Centre, which is how do we make sure that the care we are providing to our patients is as valuable as possible for the minimal amount of cost. Next slide, please. So for us to be able to do this, what we need to do is to make sure that we can use and learn from data that exists in the healthcare setting. And currently, the process of doing this is incredibly slow and cumbersome. Let's say patients arrive in the hospital, data is being collected as part of their clinical care provision. And the next step is you have a project, you submit that project for ethical approval, as has been happening in the past 20 years. And you spend maybe a year, maybe a few months extracting that data. Then you spend a bit more time cleaning it. Then you analyze that data. And then you spend some time interpreting the results and finally take action. And for you to go through this process, it takes you maybe a year, maybe a couple of years to do so. And you can imagine in certain settings, for example, like what happened now with COVID, but also for many other pathologies that can be quite complex and where treatments are evolving quickly, we need to make sure that this system is much more efficient and that we can make use of data at scale. But that obviously comes with dangers, such as patient privacy. Next slide, please. So the AI Centre, as you can see here, is a center that was created roughly 3 to 4 years ago. It started only with 2 universities and 4 hospitals, but it has grown now to 4 universities, the 4 main London research-centric universities, King's College London, UCL, Imperial, and Queen Mary's, but also 11 NHS trusts focused around London and southeast of England, but now also with a footprint in the Western Midlands. In total, we cover roughly 16 to 18 million patients in terms of coverage area. So that is roughly the population for which we have data for, if you were to look into all of these systems across all of these trusts. Next slide. So for us to be able to use these data and to be able to learn from these data, there is a huge amount of technical challenges that need to be addressed. And these technical challenges include not only technical challenges from the point of view of the engineering and of the data side of the equation, but also challenges that are technical, but are highly intertwined with governance and privacy, which we'll see in a second. Next slide, please. So the first part is, how do we make sure that data inside of a hospital is formatted in a way that we can learn from that data? Currently in the NHS, every hospital is going to store patient information in a slightly different way. There is no national standard or no national infrastructure for the patient electronic healthcare record. So what we need to do first is to create a mechanism to be able to transform the data that currently exists inside of an hospital into a structured database, into a database where the data is always formatted in the same way. We can do this on a per hospital basis. So we can go into hospital A, let's say you go into Guy's and St. Thomas's, and you take their data and you map it to another database inside Guy's and St. Thomas's, and that data is transformed in the way that is mapped to a standard that we all understand. And if we repeat the same process across all of the trusts that are part of our AI center, then we know that all of the trusts have their data stored in exactly the same way, which means an algorithm or some method or some data analytics process that works in hospital A will also work in hospital B. Next slide, please. Other types of data exist beyond just tabular data. So tabular data, which is what I was explaining in the previous slide, are relatively simplistic tables of information that contain information about blood samples, diagnoses, drugs patients are taking, and things like this. And unfortunately, EHR data is often not very complete in a hospital setting. A lot of the information in the hospital is stored in the form of a note. So some piece of text that is written by a clinician or a referring physician about the patient. And what we need to do is to have a system. In this case, we have this system developed at King's called CoaxStack, which ingests these pieces of text that are written around the patients. And then there's AI algorithms that make sense of these texts. For example, if you have these texts that you see here on the top right, that text contains certain concepts and certain nomenclatures and acronyms that can be identified. And we have algorithms that can say that, for example, on that text there at the very bottom, that text is talking about the disease, hepatitis C, and the drug ribavirin as the treatment to that specific disease. And by having algorithms that can detect all these different concepts and all of these different pieces of text, we can then use the information that is written in the reports to be able to further enrich that structured database. Next step, next slide. And lastly, we have also access to what is called the medical imaging data. So this is when you have an X-ray or a CT or an MRI of different body parts for different diseases. That imaging data is stored into a XNAT database. That's an imaging database. And some of the metadata, some of the characteristics of those images are also put into the structured database. Next slide, please. So when you put all of this information together, you can start making some really interesting queries. This was a study that was run, I believe, at KCH that shows that, for example, you can track the usage of certain stroke drugs throughout time, which is the image that you see at the top in the center. And the image at the top on the right side was the equivalent study that was done in the US that involved many people and many years of research to be able to collect that data, while the image that was collected, that was performed here within our own infrastructure, is something that was done in a few days of work, and you can get pretty similar results. So you can imagine that this can be very powerful from the point of view of understanding which drugs are being taken by different patients. And also at the bottom here, on the bottom right, you see when patients have moved from drug A to drug B or escalated to a different dose. And you can then try to understand why that happened and what is the best drugs to use for different patients. Next slide. You can also use this complex information, for example, to understand how patients move around the hospital. You can, for example, here is a plot or a diagram that shows patients moving from certain locations in the hospital to other locations in the hospital and the amount of patients in certain services. And you can use this to obviously understand where patients are in your hospital which sounds a bit strange, but you often do not know exactly, at least in a live manner, where patients exactly are in your services. But if you go to the next slide, you can also see that you can predict where these patients might be tomorrow or in a week's time, or so you can really try to understand patient flow at scale within the hospital setting. Next slide again. So this is what you can do with data. So we have transformed the data and put it into another database inside of the hospital, fully controlled by the hospital, that stores that data in a format that can be now interpreted and learned from algorithms. The second stage is the ethics process to do so, because current ethics processes takes 6 months to a year for you to get a project approved. And for many of these questions, and primarily because healthcare is so many different applications, we need to make sure that we have the appropriate ethics to explore that data. So we have a governance framework that allows us to use this data much faster than in a classic ethics process. But patients are involved in the decision-making as to which projects should or should not be approved. And each hospital is allowed to either be part or not of a project if they so wish to. So every trust has ultimate say, and patients of each one of the hospitals have ultimate say into which data is used for each project. Next slide. You then need to have relatively powerful computers to be able to learn from these data at scale. And this is something that is quite rare within the NHS. So we have built the infrastructure, the computers. We have put in computers, big computers inside of these hospitals as part of our AI center. And those computers are the ones that are used to do all the number crunching. So rather than bringing data outside and pushing it to the cloud, which is what most people would do, we actually brought the compute and put it inside of the hospital. So all the computation happens on site. Next slide. The fourth pillar is how do we make sure that the algorithms that we develop are safe, both from the point of view of software, and for that we have this very popular software package called Monai, which provides very good quality software foundation for you to develop these algorithms in a way that we are sure that, for example, they don't have any software problems and they're not going to crash or have a bug while they're running. But also safety from the point of view of making sure that these algorithms are aware when they work and when they don't work. And it's very important that algorithms understand when they are correct and when they're wrong, so that when the algorithms think that they might be making a wrong decision or a wrong diagnosis, they can always call up for a clinician or a medic or anyone with responsibility to be able to analyze that data. So they are learning to defer certain decisions to the medics that are taking care of the patients. Next slide, please. The other question that we are trying to answer is how do we go and how do we learn from data that is now scattered around multiple hospitals? So as I was saying, each hospital creates a copy of their internal data and stores it in the separate database inside of each one of the hospitals. So now we have 10 or actually 11 different databases scattered around the UK. And we need to be able to train a single algorithm that can learn from all of these different databases. And that's where something called federated learning comes in. So federated learning is a way that allows you to be able to send these AI models to all of the different locations, to all of these 11 sites. And the models themselves, the algorithms, are exchanging what they've learned from the data without exchanging the data itself. And that makes sure that you're learning from the data, but the data itself is not moving. It's always within the framework and the protections of the hospital. And the hospital, again, has ultimate say as to when and if that data can and should be used. Next slide. And as I was saying before, you can do this research by sitting outside of the hospital. So for example, here at King's College London, I could connect to our FL Hub platform, and I could send algorithms into the different hospitals. And those algorithms will run independently on all those different hospitals without me having to physically go into the hospital. But I would never have access to the data myself. The algorithms themselves will see the data when they arrive inside of the hospital, but that data will never leave, which means that we can ensure privacy via those mechanisms. Next slide. So after you can train these algorithms and you collect the knowledge about what that data looks like and how, for example, to best diagnose a patient, you need to then be able to deploy these algorithms clinically. And in this case, we build a separate system called AID, which we're not going to focus too much today, but I thought it was important that you can see what this will look like at the end. And this system is basically a way for you to deploy and deliver these algorithms in the clinical setting. So when the next patient comes in and we want to know, for example, their diagnosis, or we want to know, for example, how their disease is likely to evolve, we can run these algorithms within AID, and AID will then provide predictions and try to provide explainability of those predictions so that the clinicians can make use of that information for their own care processes. Next slide. And the system is actually currently now up and running. This is a quick demo of a patient that had a stroke. And this patient here, it gets admitted to hospital, goes to get an image because they believe the patient had a stroke. And as soon as that stroke image is acquired, that image is immediately sent into the system. And the system, for example, analyzes this image and creates a report that explains to the clinician what is the area where the lesion of the patient with a stroke has, and what that might result in terms of side effects for the patient. For example, if a lesion is in a certain part of the brain, it might cause, for example, long-term movement disability or language problems. And because of those kind of more comprehensive information, the clinicians can make better and more informed decisions about how to treat these patients next. Next slide. So really just to conclude, I just wanted to really give you a brief glimpse about the infrastructure that we built. And I think it's really important to figure out that a lot of this data is currently sitting within our hospitals and is currently there in a completely untapped form. We are not making use of this data. And obviously, we're not making use of the data because of all these privacy concerns. But with the infrastructure that we built, we can make use of this data. We can learn from this data with very minimal, actually, in this case, no impact to patient privacy, which means we can then further improve how we are treating patients and hopefully make healthcare better and more efficient in the UK. And that's it. Thank you.
Thanks, George. I found that really interesting. Particularly, I like the idea about how the NHS is always in control and has ownership of that data, and that it's not coming in and out of the hospital. I know as a patient, that would make me feel a lot happier and be quite happy to have my data involved in the learning that's going on with these AI systems. So let's move over to our panel discussion. And so each panelist, as you talk, if you haven't had a chance to introduce yourselves, please do so. So I'd like to go straight to Haleema. Can you tell us a bit about yourself, and also can you tell us what the benefits of data standardization underpinning platforms such as Flip? What kind of benefits are there?
So hi, my name is Haleema, and I work in GSTT as part of the clinical scientific computing team. And as part of our work, we are supporting the deployment and development of the platforms such as Flip and AID with the AI Center. So my background is primarily in a lot of data engineering, data curation, and I like to think the benefits of being twofold: one from a data standardization point of view, and one from Flip, the platform kind of view. If you've ever been involved in any kind of data curation, often you'll find it's an iterative process. It's a collaborative back and forth between the data engineers, the data teams, informatics teams, and the clinicians and other subject matter experts. And what we found is that it's just really hard to compare like for like sometimes, because everyone has a different way of interpreting things or classifying things. And so having a platform such as Flip, or even the idea of federated learning, dictate what is considered an acceptable data set helps impress upon people a standard model for what is data quality, what is acceptable data quality. And so as you've seen in Jorge's slides, even the way that unstructured data is processed through CogStack and assigned clinical code, having that standardized across the different federated sites means that we are all looking at the same thing and classifying it the same way. And so that improved data quality, that massive one big data set can be correctly used for model training. On the side of the platform, however, I also think there's an added bonus of just making it easier, if I'm honest, for model developers to access larger, more diverse data sets. There's built-in privacy preservation, there is a standardized and simplified data governance, and so having that infrastructure in place opens up the opportunities a lot faster and a lot more widely than it would be if you were just doing this individually.
Thanks for that. Following on from that, I wanted to ask George, can you tell us a bit about why this is preferable when you're training AI?
I mean, there's two answers there. One of them is really continuing on what Haleema was saying. The current processes for data access are not ideal before this platform was there. Everyone that wants to use data will work with hospitals to pull data out but the processes to do that are not fully standardized. And there are some risks that are inherent to pulling data out and making use of data, and standardizing that and making sure that we're doing things right once and then always using that for the future itself makes a huge difference in terms of ensuring that we're not leaking information that should not be there, or that the data has not been properly anonymized. So from the outset, following this process means that the data itself should be at much lower risk, because we know exactly what happened to the data, and that is incredibly standardized. The second part is, and this is more of about how data works, when you start looking into incredibly complex data, the idea of privacy becomes very complicated, because if I know, for example, the height and weight and postcode of the patient, like complex enough information about a patient, I will probably be able to find out who they are, right? If I know enough information about someone. And that becomes an issue, right? The data needs to be rich, and we need to have access to a lot of information about people to be able to make good predictions and diagnoses. But if we know too much, we can suddenly identify who the people are. So by using systems such as the one we developed here, you massively mitigate this risk. So me as a developer, I will not be able to see the data. I can use the data, and the algorithms will be able to see the data, but I myself will not be able to see the data, which means even if the data has complexity, which is enough for me to be able to identify the patient, the algorithm will not be able to identify the patient, because the algorithm doesn't have that intent, right? And the algorithm cannot take information out of the hospital beyond the one that is allowed to learn from, right? So in a way, by creating this system, you separate the ability to see the data, and thus the ability to identify patients and breach their privacy, from the ability to learn from the data. And ultimately, what we want is to learn from the data. We don't want to breach anyone's privacy. So by separating those two, you can get all the benefits with minimal risks.
Thanks for that. I mean, you mentioned your role as a developer. What challenges have you faced whilst developing Flip, and how did you overcome these?
Yeah, so two major challenges. One of them, this idea of installing these systems in the hospital and making sure that all the data is harmonized and put into the same format so that algorithms can work from that data. I think we've been trying to solve that problem for 20 years. The community has been trying to solve that problem for 20 years. And some of it is still unsolved. There's many different types of data that are incredibly valuable that we still do not know how to harmonize and make available for algorithms. But at least we solved a large portion of that problem. So now the algorithms can learn from that data. The second part is, as a scientist, not being able to see the data itself. In previous research, when I was not using Flip, you can see the data. You have the data on your computers, and because you've been approved to use that data. And you can do certain things by looking at the data. You can see problems that the data has, and etc. Right? If you cannot see the data, you need to solve for those problems in a way that is much more algorithmic. So the algorithms themselves need to be able to cope with a lot of the problems that that data might have. And you need to work much more closely with the different hospitals and the clinicians in the different hospitals to make sure that they themselves can, for example, identify differences in the clinical care process that might differ between sites. So it changes the scientific mindset and the scientific approach, but it's a change that is necessary, because with increase of data set size and data set complexity, we need to move into mechanisms that are able to really enforce privacy from the outset and by design, rather than just relying, for example, on behavior and training of the different researchers.
Thanks for that. Let's move over to James. James, can you first introduce yourself? And then can you let us know, how do we make the move from AI computer models to real life applications?
Hi, I'm James Steele. I'm a neurologist at King's College Hospital, and I lead a lot of the data science work within KCH and GSTT. So I have what you call a scientist hat, but I also have a clinical hat. I see patients personally on a one-to-one level, and I deliver care directly. And I think one of the there have been lots of slow attempts at implementation and translation, and this applies to many AI models which have developed over the years. And it is one thing to build an AI model, and it's completely another thing to actually implement or translate it, or to actually even use it in real world use. And a lot of that is related to the fact that the development of these models have been occurring separate from the delivery of the service, so outside of the hospital in the past. And the hospitals often have different platforms. We need to move towards common platforms or common data standards. When you build an AI model on what we call cold data that has been extracted, the process of extracting the data is often extremely manual. If you want to then take the AI model you've trained and put it back into use, you need to you still have that manual process of producing that manual data. And so in my view, a lot of this problem stems from the fact that in the hospitals, our infrastructure is too old. It is not standardized, and the data lifecycle is not fast enough to be able to make any of these systems useful. So we can make very sophisticated AI models, but it relies on the data being rapidly and easily available in a standardized format. And so the tools that do that has to be deployed in the hospitals, and the hospitals have to invest in these tools. Unfortunately, the hospitals, as we know, at the NHS is resource starved, and a lot of this infrastructure is what we call capital investment, which requires investment. And obviously, when you're investing in a hospital, you are pulled in many different directions in resource allocation, and often these things suffer. So as a result, I think to move from AI models to applications, greater effort has to be placed on very, very boring things like infrastructure, pipelines, standards, quality. These things, unfortunately, have to happen. And that until that happens, a lot of the AI models will remain exciting tools of the future, but very much of the future.
Thanks for that. Could you also tell us a bit more about vertical integration and what the wider implications are of this?
So vertical integration is a concept that's used in other industries where you kind of explore where the sources of your if you're making a product, where you're going to sell it and how you're going to distribute it. So that's downstream of your product, as well as upstream of your product. What are the components that make your product, and then being involved in production of those components as well. Vertical integration in this context in healthcare, healthcare obviously has vertical integration, but in a different aspect. We have vertical integration in terms of primary, sometimes with secondary care with tertiary care, sometimes with sourcing drugs and things like that. But that it doesn't really exist in health tech. Health tech, the health tech bit sits usually outside of the hospital. It may sit in the university, it may sit up in a commercial entity, but that sits separate from the healthcare industry. And the healthcare industry, the NHS has traditionally thought of it as a problem for someone else to deal with, as an exciting problem for someone else to deal with. But the reason it hasn't delivered is because it's a problem for someone else to deliver, and therefore the NHS has not prioritized this. However, for vertical integration to work, the NHS has to a certain degree own a lot of the processes. It has to understand the sources of the data, the whole data lifecycle, that all aspects of the data and the flow into AI models, from the development to the testing, to the validating, to the release, to the use, to the monitoring, even possibly to the regulation, needs to be integrated. And it's very difficult to integrate when there are many different parties. Often it's easier when it's integrated in a similar environment. And I think the efforts of the AI Center in trying to do a lot of the integration at the hospital level, within the hospitals rather than separated from it in academia or in commercial entities, has been helpful, because you are actually developing tools at the point of use. Eventual use, not current use, but eventual use. And therefore, the tools are more likely to be useful.
Thanks for that. Haleema, are there any anticipated challenges in integrating AI federated learning platforms specifically into NHS trusts?
Yeah, I think as George and James have kind of mentioned, I think what you might have gathered is that the key challenges are things like resource, the capacity of existing teams within organizations to support the deployment of the platform, the development of the products that are contained therein. So, for example, models within Flip and applications within Aid, the data curation stage as well. And I would say the other kind of key challenge that I think is the openness to adopt the existing processes within a trust to accept something as, I think, groundbreaking as learning within the NHS and kind of propagate that culture of AI development and AI initiatives. And so, these challenges are, I think, present in lots of industries, but because we are dealing with, very sensitive information such as, patient data, and there's a lot of, I would say, public, hesitance about AI and data sharing, I think something like Flip and this federation in general presents such a great opportunity to tackle those challenges. And I think, as James and George have already said, it's something that has more benefits than risks, and definitely tackles a lot of the longstanding issues that have been encountered when trying to develop AI locally.
Thanks for that. And actually, I wanted to ask all three of you, just really quickly, like a one-sentence answer. What do you think the most exciting prospect of integrating Flip into NHS trusts is? George, do you want to answer that first?
Yes, of course. One of the biggest issues we've been facing with development and deploying of these technologies is their accuracy and their ability to work in real-world scenarios. So what happens is, as a researcher, you work with one hospital and you work with them to collect that data, and that algorithm works well within that hospital. But if you try it elsewhere in the country, it might not. And there's many reasons for it, because different hospitals work slightly differently, they acquire the data differently, but also the ethnicity or the socioeconomic status of the patients around the hospital will change. So by increasing substantially the network of hospitals that are part of the study, you make sure that these algorithms have seen all the variants, all the different patient presentations, all the complexity that exists at the population level, which means that the algorithms have seen and know how to extrapolate to situations that they would otherwise not have seen, right? And that completely changes the performance and the robustness of these algorithms and their ability to work in the real world, and also make sure that when you deploy them, that they work in a fair way across all ethnicities, genders, and etc.
Thanks. Haleema, what do you think is the most exciting prospect of integrating Flip into the trusts?
I feel like I need to think of a new one, George, because I was going to say diversity. I think there are loads of amazing AI products and interesting research that is coming out. I do feel like, more and more we are being educated on the importance of having more diverse data sets, including, patients with various socioeconomic backgrounds, ethnicities, things like that. And, as a patient, I'd love to, contribute to development within healthcare, but at the same time, I think, like many others, I assume, I would like that to be done in a very privacy-preserving way and then have my rights respected. And so I guess if I had to add on a different answer just for flavor, I'd say it's the privacy preservation for me. It's the idea that I'm doing my part, or at least what I think is my part as a citizen in society, to contribute to the wider, research, but at the same time, just for my personal sake, know that my data is being curated and processed in a way that is ethical and sustainable.
Thanks. And just before we move on to the audience questions, James, how about you? Most exciting prospect?
I would say the most exciting prospect is actually the discovery process when deploying Flip, when we discover how all the different organizations don't know where their own data is, or know the quality of their own data, or how to source their own data. I think that's improved the level of literacy and awareness of the problems within an organization. And I think that has been extremely helpful in getting people to appreciate the iterative nature of the whole entire process. But yeah, it's perhaps a kind of a glass half empty, half full kind of perspective on it. And I think it's exciting because people begin to realize the unknown unknowns, basically, about their own estate.
Thanks. Thanks for all those comments to all three of you on the panel. We've got some questions starting up now in the chat. To the audience, this is your chance. Go ahead and type in anything you'd like to ask the panel, and we'll try to get to all of them. To start off, the first question is there any move to involve data from more trusts beyond your current footprint to be able to look at the bigger picture in the UK? I'm not sure who's this for. It looks like George maybe has unmuted himself.
Yeah, I'm very happy to go for that one. So we're already doing that. So for example, Birmingham, that has been brought in the past couple of months, is a start in that direction. Obviously, the AI Center was funded by government grants, and those grants have limits in terms of how much we can expend. But the idea is that by demonstrating the value of these platforms, and that's what we're currently working on, this become part of something that hospitals themselves will want to invest because they can benefit more than what it costs them in terms of being able to benefit their hospitals. When we are able to demonstrate those, then I think it will organically grow to the rest of the country. We are exploring processes with the NHS to make sure that these can be disseminated to the rest of the country. But the idea is indeed that we slowly propagate further north and we start bringing in populations from different areas that we currently don't cover. At the moment, the AI Center is still very Southeast London centric because it was the London AI Center at the very beginning, but we are really trying to break that wall and start going further north as quickly as we can.
Thanks for that. We've got a question from Adele, who said, a lot of the applications we hear about use imaging where there's already a well-structured data set. Do you have any examples of algorithms that have successfully used the text-based patient record files?
That one I'm sure is for James.
I was just going to say James, maybe.
Yeah. So yeah, well, obviously we at KCH and GSTT and UCLH as well, we work on a lot of unstructured text. We've been doing this for 10 years now. We have natural language processing AI tools. Most of this, we are using it for the purpose of enriching data and improving data quality and data processing. There is obviously the prospect of using it in other more direct operational tasks or even clinical decision support, but that obviously moves it into a very different realm of regulation. I think my focus at this stage is to use these natural language processing tools for improving data quality and automating various back office activity in the hospital. And so these tasks involve what the NHS do, like called clinical coding, which is assigning codes, data codes, which is a very manual process for reporting purposes, for billing purposes, for tariffs, for planning and such. We've used this during COVID for various data processing tools to accelerate the pace of data use from free text. One thing I have learned as a clinician is that no matter how much there is a desire for nice, pretty tabular data or nice, pretty pictures from radiology, doctors on the ground prefer to type. They will cheat and not fill forms. They will cheat and not click on all the buttons because that's very tedious and they are starved of time, and they will type instead or dictate. And so unstructured language, a natural language is the way forward. Well, it's not the only way forward, but it's one of the complementary tools forward, and that's why we do a lot of this work. A patient name is CogStack. You can look it up. It's an open source tool set, and we work with a big community around the country and internationally.
So following on from that, there's a question. It says, what would you do to solve the data quality problem if you had infinite time and budget?
I think certainly building on these natural language processing tools will help. You increase the amount of effort that trusts are able and capacity to convert data into interoperable formats. So unstructured data is just one, but we need to get the trust to modernize the system to common international standards, including FHIR, OMOP, and such. And a lot of these infrastructure exists in the hospital, but they're half built. So the project gets started, they deploy 10% of it, and then the person is pulled off to another emergency project, and then it's only half built. And so as a result, we have systems which can kind of do it, but we just never resourced the manpower to integrate it. And so that would be what I'll be doing, and I'll be doing it not centrally. I'll be doing it at each hospital, locally.
And just to add to what James was saying, I think there's also a need for the algorithms themselves to be able to handle data that is not of as good quality as it might be, right? At the moment, we kind of assume that algorithms need perfect data, otherwise they don't produce good outputs. But there's ways that you can make the algorithms robust to problematic data. If you were to show a clinician a blood panel where some of the numbers are completely off the charts, they would not be tricked by those. They know something went wrong in that analysis, right? They would dismiss that specific line of data. And algorithms can be trained to do exactly the same. So I think it's a mix of making sure we can collect better data, but also making sure that the algorithms themselves learn when to ignore certain data types when clearly that data is wrong.
Thanks. Haleema, you mentioned earlier on, you talked about your own sort of perspective as a patient, how you would feel happy with your data being handled in this way. There's a couple questions actually in the chat about have patients been involved in any of these conversations? I'm not sure if you're the right person to specifically ask about patient involvement, but have you got any thoughts on that?
Yeah, I'll defer to George on the details regarding the governance at the top level, but I can definitely say that patients have been consulted in the development of these platforms as part of the surrounding governance and approvals. And you know, George, correct me if I'm wrong, but in my opinion, I feel like there's been a positive response. You know, cautiously positive in the sense where a lot of their concerns were noted as valid, and there are a lot of things about these platforms and its development that speak to how carefully and how respectfully the center is treating those concerns.
So patients have been part of every single one of the steps in terms of developing the platform and how the platform was designed, to the point of us having to explain exactly the different steps of how the data is collected. For example, mechanisms for them to opt out of research. And again, national opt-out exists, and we have mechanisms to make sure that someone that opts out for research is completely opted out and their data will never be in the platforms and will not be utilized. But more than just the platforms themselves, patients that are specifically affected by certain diseases will be part of the decision-making when the project starts in that specific disease area. For example, if I now want to do a project in stroke imaging, I will need to consult with patients that have had strokes or carers of patients that have had strokes for them to be able to approve that their data should be used for this specific project. So patients will be used and patients will be asked to contribute and be part of the decisions to be able to access all data types on a per project basis, even moving forward, even though so far they've already been asked to contribute to the design of the platform itself.
I'll come in as well.
Yeah, thanks, James.
So obviously the views of patients about data, patients isn't one group. It's heterogeneous. And so as George says, that there are different patient groups with patient diseases with different viewpoints. They may give a view about a project design as a whole, what to work towards. But these are obviously, even within a disease group, there are different patients have different perspectives. And so patients who have a perspective which is more privacy favoring, they have the option to opt out of their data being used. The infrastructure has built many of these things together. But in addition to that, I think a key part of the process is also communication. So the 8th Caldecott principle on proposal is that there should be no surprises. So a part of this is these webinars, communication to our community that this work is going on and that this is in their interest and that they have the option of opting out if they wish. And this, I think, is a key part of ensuring trust in the data. We obviously want patients to participate, but we should enable them to opt out if they wish to.
Thanks. There's a few questions that, I'll be perfectly honest, for me are quite technical, and I'm just going to throw them out to all three of you and let you guys decide who's going to answer them. There's a question about including genomics data. For example, I'm going to say this wrong, I'm not a clinician, pharmacogenomics work. There's one of you who can answer that.
So we are currently, the center started as a radiology center focusing on imaging, and we then extend to other types of clinical information in the tabular form and also in the form of text. We have not gone all the way to genetics or what is called omics data, proteomics, and many other data sources or digital pathology. The platform itself is able to cater for that data, but we have not focused on those yet. And as the platform progresses and as we see uptake, then we hope that there will be further investment to increase the capabilities of the platform to be able to capture other data types that we currently do not.
Just to add a little bit to that, is the technology can be created to do that, but most trusts do not hold that data. So building it when there is no source is usually a futile exercise. So the source has to be rich enough first. And so the trusts have to do a lot more sequencing, a lot more genotyping before it is necessarily a productive activity.
Thanks. And here's another one. I'm going to let you argue over who gets to answer, because this is above my skill set here. Someone's asked about how do you control the confounds such as MRI harmonization, sociodemographics, sites, age, etc.
I can probably say that. So two things. We know where the data has been collected, and we know the metadata associated with those. And often we want systems that are almost confound free, and that's what we've been doing in science in the past. We want things to be as harmonized and randomized as we can. But actually, if we want systems to work in the real world, we want them to be able to cope with real world variability. Obviously, we will need to tell the algorithms where the data is collected, what data has been collected, and how it has been collected. And the algorithm should make use of this information to be able to make their decisions, rather than us having to harmonize all the data from the point of view of how that data has been acquired.
Thanks for that. And kind of this refers back to the something that was spoken about earlier around data and consent. Someone's asked for clarification. The question says, did I understand correctly that you're asking each patient whose data is used for consent for each use, or is the national data opt-out the only choice?
The national data opt-out will be the only choice. So we ask patients of the hospital, a group of patients, a reduced group of patients, to comment on that specific idea, scientific idea and application, and to give us insights into if they think that that's amenable or not. And then working with the Cultigot guardians, which are the people responsible for the security and privacy of data in a hospital setting, they get to approve or not approve the data to be used at scale. So individual patients are not consented individually. This is all done under what is called Section 251, which is a specific process to do that. But patients can opt out at any point via the national opt-out system. Oh, Carly, you're on mute.
Thank you. That was very 2020 of me, wasn't it? So I think this is the last question in the chat. I'll have a quick scan through to double check I haven't missed anything while you're answering it. But it's another technical one. Is statistical heterogeneity, violation of the assumption of data being identically distributed, a problem across the involved hospitals and trusts? If so, how is this handled from your federated learning platform?
That's a very technical question, but there's a specific mechanism for you to train federated learning algorithms in what is called non-IID data, which is exactly what the question was about. There's ways that you can correct for those. Obviously, it's never perfect. There needs to be some degree of overlap in terms of the population between different sites and etc. But because the populations are broad, we hope that there's some degree of bridging across those. But there's mechanisms to control for those. But the question will still remain if you were to bring data from multiple sites to a centralized location. You will still have problems of data from multiple sites being in non-IID. So the same methods that we'd use to analyze centralized data in a non-IID format can be used with tweaks in this federated setting and still be able to achieve the kind of behavior that we'd expect these models to have.
That's great, thanks. So we're just about out of time. So at this point, I would just really like to thank Jorge, Haleema, and James for joining us today and sharing all the information that you've passed on. I've found it very interesting, and I hope the audience has as well. I'd also like to invite you, all of you that have attended today, if you've enjoyed this event, we hope you'll join us for the next webinar in the series, which is called NHS in the Driving Seat, Building a Clinically Led AI Ecosystem. So thank you to our panelists, and thank you for the whole DigitalHealth.London team and the HIN and the AI Center for organizing the event. And we hope you all have a great afternoon. Thank you.